Okay, that's wonderful. So, guess what we use the product rule for?
Finding products of things.
No.
The derivative.
Of
Sine and cos.
multiplied together. Correct. Yeah.
Yeah, that's what I meant.
So,
What do we do with tan?
what do we actually we deal with tan the same way. Yeah. What is the derivative of tan, RJ?
It's like secant squared or something.
Yeah, it's secant squared, and it's not that hard to. Not
It's
that hard
stupid.
to
I don't like it.
What's that?
It's stupid.
You're down.
Easy there.
Yeah, boy.
Like,
don't
I
be
couldn't
so
even
full
talk
of hate.
yesterday, but I wasn't feeling like that.
All right. So what we're going to do, we've got the product of two functions, and we're going to derive the. We're going to find the derivative
I knew I should have took
using
pictures
first
when
principles.
you were earlier.
Oh,
I knew I should have took pictures of it.
What?
took pictures of what?
During second period, he wrote down the entire product rule on the board.
Thank you very much. Sure.
Thank you.
What's that?
Magic documents.
See magic documents, for which I haven't yet done Natalie's inner report. Okay.
Oh yeah.
So I want to find the derivative of f of x. What do I need to use?
The product rule.
The product rule. Yes, I need to start out with the difference quotient. So,
It's equal. I saw this.
and
It's px times qx, or the derivative
p at
of
x plus
qx.
h.
What?
Q at x plus h.
Just tell me some derivative of.
Yeah, this is just the difference quotient.
Yeah.
This is how you told me otherwise. This is a lie.
What's that?
It's a lie.
Already, RJ. RJ is upset already. Okay, we have to do a magic trick in here because we don't have any tools to deal with this right now. We have to do a magic trick, and here it comes. We want to be able to make this a recognizable difference quotient for p at x. And so I'm going to subtract p at x times q at x plus h. And then I'm going to add it back in so that I don't change the expression in any way. Okay, that is kind of a very abstract move.
I don't have room for it.
Yeah, I know. I'll barely have room on the chalkboard for this.
That was a little-
Okay,
Please take a couple steps back from me.
take a couple steps back. Okay.
Okay, almost, but not really.
All right. RJ, look at p at x plus h minus p at x. That looks an awful lot like the difference quotient for just the p at x function all by itself. So what we're going to do, actually, we're going to factor out this q at x plus h part.
There's a lot of those. 3.
Yeah, there's a lot of that. And so there we go. And things start to look a little bit more familiar. And I'm going to split this into two fractions, but I can do that. Yeah, it's plus. And what I'm going to do is I am going to factor, I'm going to factor p at x of these two, and that's going to leave me with the difference quotient for q at x. So I'm just going to factor p
Is
at
that
x
times
out.
bracket or minus the bracket? Like the square brackets.
Yeah, that's a times in there because I just factored it out. Yep. P at x and q at x plus h minus q at x. And that's all over h.
There's no one on that line, right? So I'm,
That's it. I have it. It's all
I'm
over.
out of room.
You're all out of room? Okay. I could come out of room too. Is it visible?
It's pretty good. Some of your cues are a wee bit.
My cues are a little bit funny.
Hi. Just because you don't know how to make one. You've been joined.
Oh, we've been joined. Muted. Is that Luke? Is he waving? Hi, Luke.
He can't see you.
He can't see me? Oh, look at
There
that.
you go. Now you
Oh,
can see
okay.
you.
Hi,
The
Luke.
camera's there.
Yeah, it's a little bit irritating. So it's irritating to look there and not there. So we're just going through the proof of the product rule, Luke. And as I mentioned, I'd mentioned earlier, this is one of those proofs I expect everybody's going to be able to reproduce, even though it's kind of ugly. So we have a function. It's a product of two functions. We just put the whole thing in the difference quotient. And then we do this magic thing where we add in something that looks kind of like a part of the difference quotient. We subtract it back out. And we start to get our two difference quotients and two functions forming down below. So I'm about to turn this thing into something that is manageable. So I'm going to erase this stuff up here, except for the limits because I'm kind of lazy. Look at that. The limits are already there. Laziness.
Well, I have my microphone muted.
Yeah, there we go. All right. That's better. How did chemistry go yesterday?
Oh, it was good.
Oh, okay, good.
Didn't take too long. It was good.
Okay, so that's the difference quotient for P at X. That's the difference quotient for Q at X. I am actually ready to, I'm ready to apply my limits here. I can actually do this right now.
Do this.
Let's do this thing. Okay. So I'm going to put h in, I'm going to find the limit as h approaches 0. Q at x plus h and h is 0. What's that? Right. It's Q at x. And then what does this become? The difference quotient. How do we write that out?
Well, it'd be P at X minus P at X, so it's 0.
It's actually, it's the derivative of P at x.
But it's P at X minus P at X.
Well, it's P at x plus h minus P at
And if
x.
you put it in 0, it's P at X.
Well, I'm dividing it by h though. So it's just, it's the difference quotient. So
Oh, I see what you mean.
yeah, so it's actually the derivative.
Action.
Yeah, pretty handy, eh? And then plus P at x times Q prime at x. So this is the difference quotient. This winds up being the derivative of the function Q of x with respect to x. So there we go. That's it.
Divided by 8, right?
No, because I applied my
Oh, you did
limit.
that.
The
Okay.
h is all gone.
Sorry.
Yeah, that's right. And fortunately, because I'm applying the limit, I don't end up with the division by 0 thing happening there. So it's just, there it is. That's the product rule. And normally I sing a little song about it. First times the derivative of the second plus second times the derivative of the first, but you turn it into a chant. It's pretty cool. Okay. Is everybody good with that? So, this is like the second times the derivative of the first function plus the first times the derivative of the second function. Second times
Gotcha.
the, yeah, and you could put it in any order. First times the derivative of the second plus the second times the derivative of the first. Doesn't matter. Okay. Luke, what's the derivative of sine x?
What?
Oh, sorry, you're coming through kind of spotty. Do you know what the derivative of sine x is?
Pyramid? Sorry.
Yeah.
He can't see you looking at
Oh,
him.
he can't see. Okay, jeez. Yeah.
No.
Oh, okay. So the derivative of sine x is cos x. You don't actually have to know this technically for this lesson, so it should be all right. Okay, let's do some examples.
What?
Okay. So let's find the derivative of hx. Oops. So we're just dealing with all polynomial functions.
I'm just wearing the wrong coat. Oops.
Like very sciencey.
I am very sciencey.
Yeah. Okay. So it always seems a little artificial because these are like two polynomial functions, and if you're of the arguing type, you'd say I could just expand this and take the derivative, and it would be easy, and you would be right. There would be nothing wrong with saying that. Okay. Sometimes it's nice to break these things up into the two functions. What's my first function? 4x squared. Very good. What's the derivative of the first function?
8x.
8x.
I think it's a cube.
Excellent. Yeah, that's a cube. People
Yeah,
are
it's kinda hard to tell on the
questioning.
screen.
It's hard to tell. Okay. What? That's a perfect cube on my screen.
Your screen's so clear. Ours was just kind of like.
Luke can see, right, Luke?
Yeah, that's good.
Okay.
RJ says his headache's messing with his vision, so.
Oh, okay. All right. Okay. P at x. Who wants to take a shot at P at x? What is it, first of all?
2x cubed minus 4x plus 9.
2x cubed minus 4x plus 9. Yeah. And P primed at x?
6x squared minus 4.
Yes, sir. That's actually all we need to. That's all we need to move ahead, move forward. Okay.
I can handle that.
Yeah, it's pretty easy. The hardest thing is maybe the proof, and it's because it's got that counterintuitive thing. Okay, if I erase this, pretty cute. Cool with that? Okay, so 4x squared times 6x squared minus 4 plus, tell me if I get this wrong, 2x cubed minus 4x plus 9 times 8x. What a mess. And you know, you can expand that if you like, and collect like terms, or you can leave it like that. It'll tell you if you're supposed to expand it or not. Okay. Everybody cool with that? You gonna look at the camera? Cool with that, Luke?
Yeah.
All right. Ready for another example?
Yeah.
Okay. You guys have that?
Yeah. Seriously, do you want to? Okay. You just look like you're dying, and I feel bad.
Yeah. RJ would be the first person to die in the middle of a video conference.
You don't lose though.
You know, RJ, if you do that, I'm going to get an awful lot of views on YouTube, right?
We're gonna get on the popular page.
Shane says you'd like to talk about that, right?
What's that?
Shane says like you would like to talk
Like to talk
your
about-
channel.
My YouTube channel. Oh, that's a little bit of an exaggeration.
He says you want to talk from an entire period about it.
Okay, that's it. We're going to have a meetup after school. Okay.
He said something about his teacher being mean to do.
Okay. What's P, Q? P, what's P at X?
root x plus 1.
Root x plus,
Yes, this
oh
is-
yeah, root x plus
We're
1.
doing a new example.
Very good.
Get with it.
What's q at x?
It shouldn't say f prime, should it?
Oh, yeah, you're right. It shouldn't say f prime. Apologies, all you folks at home. Shouldn't say f prime. Q at x.
3x squared minus
3x squared minus 5x.
3x squared minus 5x. Good. Oh, darn it. I'm doing my p primes below. I did them the other way
Yeah, that's
on
why I
before.
was really, that's why I had that like, oh my god, look. What are you doing?
The oh my god, look. It's going in a different order. Hey,
I'll help you.
hey, what's your language? This is the internet.
It's the internet.
Do I have to convert this into an exponent and then take the derivative using the power rule?
Yeah.
So this is the x to the 1/2 plus 1. So what's the derivative of that?
Half x minus, or half x negative to the exponent.
Half x to the negative
You know
1/2 plus 1. Yeah? That's
Yeah,
right.
that.
Yeah,
Just can't
that's
speak.
it. Okay. And when you get super cool at it, you'll recognize how to manage that radical right away.
Super cool.
Cute. Yeah, we have different levels of coolness.
6x minus 5.
6x minus 5.
Nice.
Oh, and
Yeah,
thanks for pointing out that.
I was going to. They didn't even pick it up though.
Okay. Did we do derivative of the first times the second? We did, didn't we?
Did we?
Well, I always sing the song the other way around. Okay, so f prime at x is equal to the derivative of the first times the second.
Did you just do a derivative?
Pardon me?
No, he's just doing it differently.
Oh, alright.
Yeah.
I see.
Plus
No,
the derivative of the second times the first.
When,
Oh,
like,
look.
does it matter?
Hey,
when you,
hey everybody, what's wrong with my p at x
Yeah, I was
derivative?
gonna be like, well, what are you writing?
What's wrong with this derivative?
There shouldn't be a 1 there.
Yeah, derivative of a constant.
Uh,
There we go. Sorry, everybody.
So.
Yeah.
It's derivative of the first, right? So that should that not be,
That should not have, should that?
Shouldn't
Yeah,
shouldn't have
that
a
should be
that shouldn't have a one.
and does it
That should have
matter,
a one.
like, do you need to keep it in exponent form, or can you put it back with, like, the root?
Yeah, you can put it back.
I don't like that.
Yeah. Yeah, you can leave it as an exponent. It might. I don't know. It's a style thing.
I just like it better.
People fell in love with surds a long time ago. Believe it or not, these are called surds. Isn't that absurd?
Who's surds? Why are people in love with them? I like that. I'm in my webcam and you're just like,
I'm trying to see past the tower.
it was just kind of fun.
All right.
You're still going in my webcam.
So that is the derivative, and it's unsimplified. If you look in your notes, actually, you find that the derivative of this particular function does not exist for x being equal to or less than 0. Okay. As long as you're greater than 0, everything is fine. But the derivative does not exist at 0 because the left-hand limit does not equal the right-hand limit. A little bit of weirdness. Okay. Everybody good? Okay.
I'm just glad that this isn't you don't look in the mood.
So last thing we're going to do, so these are all just examples with polynomial functions. Some of them done incorrectly, just to keep you on your toes, is the derivative of three functions multiplied together.